Hi, this is Dave Johnson. Welcome to another edition of Math Off Topics. And today we want to talk about the average value of a function, which is one of those topics that's not covered very thoroughly in a Calculus 1 course. It's usually one of the applications of integration, one of the early applications that you see. And uh, so there are a couple of definitions for the average value of a function. The one that's most standard is the one that's given in the textbooks. And I'm going to show you in a minute the formula for it. But let me just give you a little preface. I was never very satisfied with this definition. In fact, I almost didn't believe it myself, both as a student and as a teacher. And when I became a teacher of calculus, I decided to come up with a better way of explaining it. And so that's what I'm going to share with you today. So let's get into this. So average value of function. And what I've shown you here is a typical function f of x. It doesn't always have to be in the first quadrant, doesn't have to be above the x-axis, but for simplicity, I'm showing you it this way. The red horizontal line is meant to represent the average value of the function. In other words, where is the function kind of midway between the low and the high? Where does it sort of average the values of the y values of the function, and so on? It's what I'm giving you is a very vague, admittedly vague definition of average value of a function. Well, the standard definition is the following, where they're showing you. So let's look at b minus a. That's the width of the interval between a and b times the height of the function, the average value of the height. So b minus a times f average. And what they're saying is, let's let that be the area under the function. So we all know, because we've studied the definite integral in calculus 1, the area under the function from a to b is the integral from a to b of f of x dx. Okay, so we're experts on that. But I don't know if you really believe that this red line corresponds to the average value of function. What does it even mean? And of course, if you divide both sides of this equation by b minus a, you get f average is equal to 1 divided by b minus a times the integral from a to b of f of x dx. So that is the definition, or if you like, the formula for calculating the average value of a function. But again, as I said, this is a very unsatisfying definition as far as I'm concerned. And yet, this is the definition that you see in most calculus textbooks. I'm not saying that the formula is wrong. What I'm saying is the definition is not very satisfying. And so, what I want to do is just give you a different derivation of the formula. Now, you might say, well, how would you do that? Well, okay. So when I originally thought about this, I pondered it a little bit and I said, well, I think the average value is the average of the list of values of f, right? And so if we start by labeling, let's say this is f1, this is f2, f3, and so on. And I've divided it up so that there's 8 of them. So let's say f sub 8. Okay. So how would we find the average of those numbers? Well, we'll say f average, and this is going to be an approximation because we're only looking at 8 values of the function between a and b. But what would it be? Well, it'd be the summation from I equal 1 to 8 of f sub I. So f sub I are our values, but we have to divide by the number of numbers, and in this case, there are 8 of them. Okay. And in general, I could say, well, this is the same as 1 over 8 times the summation from I equal 1 to 8 of f sub I, because multiplying by 1 over 8 is the same as dividing by 8. Now, where am I going with this? I think you all know that we don't want to just have 8 values. We're going to have n, let's say. So the average value is, and we'll say again, this is an approximation, is 1 over n times the summation I equal 1 to n of f sub I. Okay. And that is the average value of the function. I mean, there's no doubt about that, right? That's at least our high school understanding of average. In fact, some of us knew this back in grade school. I mean, this is what we call an average value of a function, or of a list of numbers. Okay, well, um, somehow we're going to have to get this related to an integral. And if we think about the integration process, what is, if we remember from our discussion of definite integrals, delta x is equal to b minus a divided by n. Okay, that's just how we, if we're assuming that the delta x's are all of equal length, and I think at this level we do. Later on, if you go on in mathematics, you may see that the delta x can change, but for this simple approach, delta x is b minus a over n. We're dividing the interval from a to b into n subintervals, all of equal length. Well, okay, so if I want 1 over n, if I divide both sides by b minus a, I get 1 over n is equal to delta x divided by b minus a. All I did there was divide both sides of that equation by b minus a, and I get 1 over n is equal to delta x divided by b minus a. Now we can substitute in, replace the 1 over n in this formula and say, well, f average is approximately equal to 1 over n, but that's delta x divided by b minus a times the summation I equals 1 to n of f sub I. Okay. And one of the properties of the summation, the sigma notation, is that we can move constant factors in and out of the summation sign. I want to leave the 1 over b minus a out. I'm going to move the delta x in. And so I can rewrite this as delta x. I'm sorry, I'm moving the delta x inside. And leaving the 1 over b minus a on the outside. So 1 over b minus a times summation I equals 1 to n. And now it's going to be f sub I times delta x. Now, another way to think of that f sub I is it's f of x sub I. So let me write that. So 1 over b minus a times the summation I equals 1 to n of f of x sub I times delta x, where, let's just remind ourselves, the x sub I is equal to a plus I times delta x. Now, that comes straight from the definition of the definite integral, Riemann sum. And this is starting to look a little familiar, right? This is part of the definition of a definite integral in terms of a Riemann sum. What are we missing here? What little fact are we kind of omitting? Well, we only counted up n. We started with 8, but we kind of generalized that to n values of f. But in order to get an accurate measure of the average value of the function, we don't want a finite n. What do we want to do? This is calculus. What do? You take the limit as n goes to infinity. And so I can remove the approximately equal, and I can say f average is actually equal to the limit as n goes to infinity of 1 over b minus a times the summation I equals 1 to n of f of x sub I times delta x. Now, some people will put a little star here above the, or maybe superscript on the x sub I. You can do that. You don't have to do that because when you take the limit as n goes to infinity, the delta x becomes infinitely small and doesn't matter which value of x sub I you choose in that interval. And so I can move the 1 over b minus a out of the limit because the 1 over b minus a doesn't depend on n. So I can write this as 1 over b minus a times the limit as n goes to infinity, again, of the summation I equals 1 to n of f of x sub I times delta x. Well, okay, so this should be looking familiar. What is that? Well, it's the integral from a to b of f of x dx. And now we see that indeed f average is really 1 over b minus a times the integral from a to b of f of x dx. And we've just proven the formula that we got. Remember how we got it originally? We said, let's make that rectangle between the red line and the x-axis and the lines A and B, make that area, so b minus a times f average is equal to the integral of f of x dx, the area under the curve, which to me was not a satisfying definition, but now we show now that it actually is the same formula. And so I'm going to box this formula. And now we know exactly where it comes from. So I do have some more things to say about this, but I'll do that in another video. If you found this video useful, subscribe to my channel. And if you would like to, go ahead and put a like on that video. And I'll see you next time.